大家好，我是 Aaron，欢迎来到 Aaron 的理财视角。在看财报的时候啊，很多人都只关注营收、毛利率或是特斯拉的车辆交付数，但是其实啊，真正的关键往往藏在财报电话会议的提问环节当中。这一段啊，并不是照本宣科的财报朗读，而是由华尔街最顶尖的分析师提问，像是摩根士丹利、摩根大通、高盛美商、花旗、美银这些投行，他们会直接问马斯克关于 Robotaxi、AI、能源事业，甚至是人形机器人 Optimus 的具体进展，而马斯克的回答啊，往往会透露出特斯拉的下一阶段真实的方向。而在这支影片里啊，我就要带大家看懂这部分的重点，资讯量非常的庞大，所以我会把它分成上集跟下集来讲，让大家更能够完整的理解这场对话当中特斯拉未来战略的雏形。另外啊，这次所有的英文对话我都会用 AI 重新配音，目的非常的单纯，就是让语速更加的稳健，发音更加的清晰，听起来更好听懂。希望能让大家在听这些真实问答的时候有更自然、更专业的听觉体验。
Now let's go to investor questions. From say.com, the first question is, what are the latest robotaxi metrics, fleet size, cumulative miles, rides completed, intervention rates? And when will safety drivers be removed? What are the obstacles still preventing unsupervised Fsd from being deployed to customer vehicles?
I'll start off with that, and then Ashok can elaborate. But we are expecting to have no safety drivers in at least large parts of Austin by the end of this year. So within a few months, we expect to have no safety drivers at all, at least in parts of Austin. We're obviously being very cautious about the deployment. So our goal is to be actually paranoid about deployment because obviously, even one accident will be front-page headline news worldwide. So it's better for us to take a cautious approach here. But we do expect to have no safety drivers in the car in Austin within a few months. I think that's perhaps the most important data point. And then we do expect to be operating Robotaxi in, I think, about 8 to 10 metro areas by the end of the year. It depends on various regulatory approvals. But you can actually, I think most of our regulatory applications are online. You can kind of see them because they're public information. But we expect to be operating in Nevada and Florida and Arizona by the end of the year. Ashok?
Yes. We continue to operate our fleet in Austin without anyone in the driver's seat, and we have covered more than 0.25 million miles with that. And then in the Bay Area, where we still have a person in the driver's seat because of the regulations, we crossed more than 1 million miles. So, and we continue to see that the fleet, Robotaxi fleet works really well. Customers are really happy, and there's no notable issues. On the customer side, customers have used Fsd supervised for a total of 6 billion miles as of yesterday. So that's like a big milestone. And overall, the safety continues to be very good. And as Elon mentioned, we are on track to remove the person from inside the car altogether, starting with Austin. Great. The next question is, what is the demand and backlog for Megapack, Powerwall, solar or energy storage systems? With the current AI boom, is Tesla planning to supply power to other hyperscalers? Thanks. Demand for Megapack and Powerwall continues to be really strong into next year. We received very strong positive customer feedback on our Megablock product, which will begin shipping next year out of Houston. And we're seeing remarkable growth in the demand for AI and data center applications as hyperscalers and utilities have seen the versatility of the Megapack product to increase reliability and relieve grid constraints, as Elon was talking about. We've also seen a surge in residential solar demand in the US due to policy changes, which we expect to continue into the first half of 2026 as we introduce the new solar lease product. And we also began production of our Tesla residential solar panel in our Buffalo factory, and we will be shipping that to customers starting Q1. The panel has industry-leading aesthetics and shape performance and demonstrates our continued commitment to US manufacturing. Great. Thank you, Mike. Unfortunately, the next question is related to future products. This is not the appropriate venue to cover that. So we're going to have to skip it. The question after that is, what are the present challenges in bringing Optimus to market, considering app control software, engineering hardware, training general mobility models, training task-specific models, training voice models, implementing manufacturing and establishing supply chains.
Yes. I mean, bringing Optimus to market is an incredibly difficult task, to be clear. It's not like some walk in the park at some point. I mean, actually, technically, Optimus can walk in the park right now. And we do have Optimus robots that walk around our offices at our engineering headquarters in Palo Alto, California, basically 24 hours a day, 7 days a week. So any visitors that come by, you can stop one of the Optimus robots and ask it to take you somewhere, and it will literally take you to that meeting room or that location in the building. So I don't want to downplay the difficulty of Optimus. It's an incredibly difficult thing, especially it's difficult to create a hand that is as dexterous and capable as the human hand, the human hand is an incredible thing that the more you study the human hand, the more incredible you realize the human hand is and why you need 4 fingers and a thumb, why the fingers have certain degrees of freedom, why the various muscles are of different strengths, the fingers are of different lengths. And it turns out, actually, that those are all there for a reason. And so making the hand and forearm, because most of the actuators, just like the human hand, the muscles that control your hand are actually primarily in your forearm. The Optimus hand and forearm is an incredibly difficult engineering challenge. I'd say it's more difficult than the rest from an electromechanical standpoint, the forearm and hand is more difficult than the entire rest of the robot. But really, in order to have a useful generalized robot, you do need an incredible hand. And then you need the real-world AI, and you need to be able to scale up that production to have it be relevant, because it's not relevant if it's just a few hundred robots. So you need to be able to make Optimus robots at volumes comparable to vehicles, if not significantly higher. So you're trying to make 1 million or something per year, trying to make 1 million Optimus robots per year. That manufacturing challenge is immense, considering that the supply chain doesn't exist. So with cars, you've got an existing supply chain. With computers, you've got an existing supply chain. With a humanoid robot, there is no supply chain. So in order to manufacture that, Tesla actually has to be very vertically integrated and manufacture very deep into the supply chain, manufacture the parts internally because there just is no supply chain. So this is the kind of thing where I'm like, if I put myself in the position of a startup trying to make a humanoid robot, I'm like, I don't know how to do it without an immense amount of manufacturing technology. So that's why I think like Tesla is in almost a unique position when you consider manufacturing technology scaling, real-world AI, and a truly dexterous hand. Those are generally the things that are missing when you read about other robots that just don't have those 3 things. So I think we can achieve all those 3 things with an immense amount of work. And that is the game plan. So like my fundamental concern with regard to how much voting control I have in Tesla is, if I go ahead and build this enormous robot army, can I just be outset at some point in the future? That's my biggest concern. That is really the only thing I'm trying to address with this so-called compensation, but it's not like I'm going to go spend the money. It's just if we build this robot army, do I have at least a strong influence over that robot army, not control, but a strong influence? That's what it comes down to in a nutshell. Like, I don't feel comfortable building that robot army if I don't have at least a strong influence.
Great. Thank you. We've already covered robotaxi expansion. Unfortunately, the question after that is another future product question, so we're going to have to skip that. The next one, though, is, can you update us on the $16.5 billion Samsung chip deal in Taylor? Given the importance of semiconductors to autonomy and Tesla's AI-driven future, what gives you confidence Samsung can fulfill AI6 at Tesla's timelines and achieve relatively better yields and cost versus TSMC?
Okay. So I'm going to give quite a long answer to this question because I have to unpack this question and then answer the unpacked version. So first of all, I have nothing but great things to say about Samsung. They're an amazing company, and Samsung is worth noting, does manufacture our AI4 computer and does a great job doing that. So now with the AI5, and I need to make a point of clarification relative to some comments I've made publicly before, which is we're actually going to focus both TSMC and Samsung initially on AI5. So the AI5 chip designed by Tesla I think it's an amazing design. I have spent almost every weekend for the last few months with the chip design team working on AI5. And I don't hand out praise easily, but I have to say that I think the Tesla chip team is really designing an incredible chip here. This is, by some metrics, the AI5 chip will be 40x better than the AI4 chip, not 40%, 40x, because we have a detailed understanding of the entire software and hardware stack. So we're designing the hardware to address all of the pain points in software. So I don't think there really isn't anyone that's doing this, the entire stack all the way through real world, kind of calibrating against the real world where you've got cars and robots in real world that we know what the chip needs to do, and we know what, just as importantly, we know what the chip doesn't need to do. To sort of give you some examples here, with the AI5, we deleted the legacy GPU or the traditional GPU, it's an AI4. But AI5 does not have, we just deleted the legacy GPU because it basically is a GPU. So we also deleted the image signal processor. And there's a long list actually of deletions that are very important. As a result of these deletions, we can actually fit AI5 in a half reticle and with good margin for the traces from the memory to the Tesla chip accelerators, the ARM CPU cores, and the PCIX, sort of the PCI blocks. So this is a beautiful chip. I've hoarded so much life energy into this chip personally. And I'm confident this is going to be a winner next level. So it makes sense to have both Samsung and TSMC focus on AI5. And so technically, the Samsung fab has slightly more advanced equipment than the TSMC fab. These will both be made in the US, one TSMC in Arizona, Samsung in Texas. But we're going to make, starting off just to be confident of having our explicit goal is to have an oversupply of AI5 chips, because if we have too many AI5 chips for the cars and robots, we can always put them in the data center. So we already use AI4 for training in our data centers. So we use a combination of AI4 and NVIDIA hardware. So we're not about to replace NVIDIA, to be clear, but we do use both in combination, AI4 and NVIDIA hardware. And the AI5 excess production we can always put in our data centers. NVIDIA keeps improving. The challenge that they have is that they've got to satisfy a large range, a lot of requirements from a lot of customers, but Tesla only has to satisfy requirements from one customer, that's Tesla. That makes the design job radically easier and means we can delete a lot of complexity from the chip. I can't emphasize how important this is. So when you look at the various logic blocks in the chip, as you increase the number of logic blocks, you also increase the interconnections between the logic blocks. So you can think of it like there's highways, how many highways do you need to connect the various parts of the chip? And especially if you're not sure how much data is going to go between each logic block on the chip, then you kind of end up having giant highways going all over the place. It's it becomes an almost impossibly difficult design problem. And NVIDIA has done an amazing job of dealing with almost an impossibly difficult set of requirements. But in our case, we're going for radical simplicity. And the net effect is that I think AI5 will be the best performance per watt, maybe by a factor of 2 or 3, and the best performance per dollar for AI, maybe by a factor of 10. So the proof is in the pudding. So obviously, we need to actually get the chip made and made at scale. But that's what it looks like.
Great. Thank you, Elon. We've already covered unsupervised FSD. So, the next question is, instead of trying to replace hardware 3 with hardware 4, why not give an equal incentive to trade in for a new vehicle?
Yes. We've not completely given up on hardware 3. However, over the last year, we've offered the customers the option to transfer FSD to their new vehicle, which at times we've been running some promotions. If they got FSD, they could get better preferential rates. So we've been definitely taking care of this, but we do want to solve autonomy first, and then we'll come back with a way to take care of these customers. These customers are very important. They were the early adapters. For what it's worth, my daily commuter is a hardware 3 car, which I use FSD on a daily basis. So we will definitely take care of you guys. In addition, once the V14 release series is fully done, we are planning on working on a V14 Lite version for hardware 3, probably expected in Q2 next year. Awesome. Thanks, Ashok. Our final question from Say is, how long until we see self-driving Tesla semi-trucks? And could you see this technology replacing trains? Yes. So I guess I'll start with that in terms of the semi-production plan and schedule. So the factory is going on schedule. We've completed the building and are installing the equipment now. We've got our fleet of validation trucks driving on the road. We'll have larger builds towards the end of this year and then our first online builds in the first part of next year, ramping into the Q2 timing with real volume coming in the back half of the year. So that's going quite well, and that's the first step, obviously, getting autonomous trucks on the road. In terms of trains, they're really great for long point-to-point deliveries. They're super efficient, but that last mile, the load, unload can be better served for shorter distances with autonomous semis, and that would be great. And so we do expect that to probably shift as we really, as Elon said, change the way transportation is considered. And so we're looking forward to that timeline. And Ashok, I know you can take the full self-driving part. Currently, the team is super focused on solving for passenger vehicle autonomy. That said, the same technology will extend quite easily to the semi-truck once we have a little bit of data from the semi-trucks. Great. And now we will move over to analyst questions. The first question comes from Emmanuel at Wolf.
So Elon, you talked about expanding production of vehicles as fast as possible now that you have confidence in the unsupervised autonomy. How should we think about that in the context of your existing capacity of 3 million units? Is that where you're hoping to get volume to? What sort of timeline are we talking about? And would this require some level of boosting or incentivizing demand? Like, would this basically be prioritizing volume over near-term profitability given the longer-term opportunity?
Well, our capacity isn't quite 3 million, but it will be 3 million at some point. Aspirationally, it could be 3 million we could probably hit an annualized rate of 3 million within 24 months, I think maybe less than 24 months. Bearing in mind, like, there's an entire supply chain, like a vast supply chain that's got to also move in tandem with that. So we're going to expand production as fast as we can and as fast as our suppliers can sort of keep up with it. And then we're going to think about where do we build incremental factories beyond that. The single biggest expansion in production will be the Cybercab, which starts production in Q2 next year. That's really a vehicle that's optimized for full autonomy. It in fact does not have a steering wheel or pedals and is really an engineering optimization on minimizing cost per, like fully considered cost per mile of operation. So that's for the 4 other vehicles. They still have a little bit of the horseless carriage thing going on where obviously if you've got steering wheels and pedals and you're designing a car that people might want to go very fast acceleration and tight cornering like high-performance cars, then you're going to design a different car than one that is optimized for a comfortable ride, but doesn't expect to go past sort of 85 or 90 miles an hour. And it's just aiming for a gentle ride the whole time. That's what Cybercab is. So yes, do I think we'll sacrifice margins? I don't think so. I think the demand will be pretty nutty. Like, here's the killer app really, what it comes down to is, can you text while you're in the car? And if you tell someone, yes, the car is now so good, you can be on your phone and text the entire time while you're in the car. It's anyone who can buy the car will buy the car, and it's end of story. So that's what everybody wants to do. In fact, not everyone wants to do, they do that. And that's why, in fact, the reason you've seen like there's been an uptick in accidents pretty much worldwide is because people are texting and driving. So autopilot actually dramatically improves the safety here because if somebody is looking down their phone, they're not driving very well. So that's really the game changer. And we do see, like, at this point, I feel essentially 100% confident. I'd say not essentially 100% confident that we can solve unsupervised full self-driving at a safety level much greater than human. So we've released 14.1. We've got a technology roadmap that's, I think, pretty amazing. We'll be adding reasoning to the car. Our world simulator for reinforcement learning is pretty incredible. Like, when you see the Tesla reality simulator, you can't tell a difference between the video that's generated by the Tesla reality simulator and the actual video. It looks exactly the same. So that allows us to have a very powerful reinforcement learning loop to further improve the Tesla AI. We're going to be increasing the parameter count by an order of magnitude. That's not in 14.1. There are also a number of other improvements to the AI just that are quite radical. So this car will feel like it is a living creature. That's how good the AI will get with the AI4 computer just before AI5. And then AI5, like I said, is by some metrics 40x better. Let's just say safely it's a 10x improvement. So it might almost be too much intelligence for a car. I do wonder, like, how much intelligence should you have in a car? It might get bored actually. And then one of the things I thought, like, if we got all these cars that maybe are bored while they're if they are bored, we could actually have a giant distributed inference fleet and say like, well, if they're not actively driving, let's just have a giant distributed inference fleet. At some point, if you've got like tens of millions of cars in the fleet, or maybe at some point 100 million cars in the fleet, and let's say they had at that point, I don't know, a kilowatt of inference capability, of high-performance inference capability, that's 100 gigawatts of inference distributed with power and cooling, with cooling and power conversion taken care of. So that seems like a pretty significant asset.
Elon, I know that Tesla is really focused on with master plan for bringing AI into the physical world. And I think we've seen over the past this willingness for Tesla to engage and go into new markets, new TAMs. So when you think about the growth prospects, how do we define the areas that are really within Tesla's core competency versus where do you draw the line for markets or AI applications that are outside of Tesla's core competency?
Actually, I'm not sure what you mean by AI applications outside of Tesla's core competency. But we didn't have any of these core competencies when we started. So it's like we had 0 core competencies, total competency of 0 actually. So I mean, you can think of Tesla as like, I don't know, a dozen startups in one company. And I've initiated every one of those startups. So we weren't used to make battery packs, stationary battery packs, but now we do. We make them for the home, make them for utility scale with Powerwall Megapack. We've created the supercharger network globally. No one else has created a global supercharger network. In fact, that North American supercharger network is so good that basically every other manufacturer in North America has converted to our standard and uses the Tesla supercharger network. But if it was so easy, why don't they just do it? And the chip design team started that from scratch. The Tesla AI software team was started from scratch. I literally just say, hey, we're going to start this thing. I post it on Twitter, now X, and then join us if you'd like to build it. In fact, Ashok was, I believe, the first person I interviewed for the Tesla Autopilot team, which we now call Tesla AI software team because it is the AI software team. So its core competency is created while you wait. And Optimus at scale is the infinite money glitch. It's like it's difficult to express the magnitude of, like if you've got something like that, like if Optimus, I think, probably achieve 5x the productivity of a person per year because it can operate 24/7, it doesn't even need to charge. Can operate at tethered. So it's plugged in the whole time. So that's why I call it like if you're true of sustainable abundance where working will be optional. There's a limit to how much AI can do in terms of enhancing the productivity of humans, but there is not really a limit to AI that is embodied. That's why I call the infinite money glitch.
I mean, one thing which I'll further add is, people forget like our first attrition of autopilot was 10 years back. So Elon had started this way back in the day.
Yes, we got the tweets to prove it.
好了，看完冗长的电话会议的上半部分我们先稍微总结一下5个重点。特斯拉的 Robotaxi 无人驾驶的进展。马斯克表示今年底奥斯汀将开始部分区域没有安全驾驶员的运行，并且预计在年底前8到10个都会区都会开放 Robotaxi。目前特斯拉的自动驾驶技术累积行程已经超过了60亿英里。奥斯汀无人驾驶车队行驶已经超过了25万英里。再看到第二个是 AI 晶片的以及预算能力的提升。马斯克有提到下一代 AI5 的晶片将由台积电跟三星共同代工，预计每瓦效能提升2到3倍，每1个美元能够提升效能大约10倍。这代表着特斯拉在自研 AI 晶片领域不再需要仰赖 NVIDIA， 而是未来自驾以及 Optimus 的核心技术基础。再来第3个，也就是 Optimus 人形机器人的进展。马斯克坦言手的部分是最大的困难，但是团队已经进入量产前的测试阶段。他目前的目标是1年量产100万台，但是也强调需要制造流程去配合它。再来第4大重点也就是能源事业稳定的成长 ，Megapay、Powerwall、太阳能等产品需求持续的上升。Buffalo 的工厂已经开始量产住宅太阳能的设备。特斯拉表示明年起 Mega Block 系列会开始出货，成为下一个主要的获利来源之一。 而下一大亮点呢，就是特斯拉的硬体升级计划。Semi 电动卡车呢，将会在今年底完成验证车队运行，2026年明年的 Q1 会正式的量产。此外啊，针对旧款的车主，特斯拉将推出 V14轻量版的软体，让使用 Hardware 3的车辆也能够体验下一代的 Fsd。好了，这集就跟大家看到这边。下一集啊，我们将继续解析电话环节中的下半场部分。有任何问题，欢迎在下面留言。我是 Aaron，我们下集再见。